Okay, so this may possibly be one of the weirdest demonstrations I've ever done, but that's okay, because it's going to make sense when I tell you in a little bit what I'm doing. I'm going to explain Newton's universal law of gravitation. And that just says that gravity is a force between two objects that have mass. So these are my two objects, and when I think, so first of all, it says that there's an attractive force between two masses. When I think of attraction, honestly, it may just be the hormone 18-year-old in me, but I think of a guy and a girl, okay, attracted to each other. Ooh la la. Okay, so there's an attractive force between the two. Second off, the second part to this is that the mass of her multiplied by the mass of him is proportionate to the force between the two. So that means if we were to double the mass, okay, let's say this little guy comes along, he wants in on this, sees the fine lady, wants in on this, then the force would increase by a factor of 2, okay? Greater force. Double the mass, increase the force by a factor of 2. Okay, let's take this guy away now. Third part to this law is that the force is inversely proportionate to the distance between the two masses. Between the square of the distance. So the force, I said that wrong, sorry. The force is inversely proportional to the square of the distance. So let's say we double the distance. So double will be 2, right? We double the distance between the two. 2 squared is 4. So the attractive force here would decrease by a factor of 4. Less attraction here. Less attraction between the two. Greater distance, less attractive force. So we can, in equation form, think of this as F equals G, constants, M1 times M2, G times M1 times M2 over R squared. So that is Newton's universal law of gravitation.